Hey folks, welcome to the video where I'm going to teach you guys now how to simplify cube roots. So far in the whole entire unit, we've been focusing on how to just take the square root of something that might not be a perfect square. And so I want to point out that today, instead of it just being a square root, we're going to see a number right here that's a 3. So that's how you know we're now looking for cube roots. Now, before I do anything on this page, I just wanted to remind you guys about the exponent of 3. And so if you were to see a 2 cubed, that means you're basically doing 2 times 2 times 2, which is going to be an 8. If we saw a 3 cubed, that's 3 times 3 times 3. And so 3 times 3 is 9, times 3 again would be a 27. And if we had 4 cubed, 4 times 4 is 16, and 16 times 4 is 64. So these numbers over here are called perfect cubes. And so if I wanted to know, hey, what's the cube root of 8? You would tell me the answer is 2. If I wanted to know the cube root of 27, you would tell me 3. And if I wanted to know the cube root of 64, not the square root would be an 8, but the cube root here is a 4. So just like we have perfect squares, we do have things called perfect cubes. And so today in our notes, when we're trying to simplify cube roots, it's the same concept as simplifying square roots when we looked for pairs, except this time we're just going to look for triplets. I'll remind you guys what I mean by look for pairs. Earlier in the unit, when we saw this problem, we broke it down and you circled 2 at a time, and that's what came out. So when you're looking for a square root, you circle the pairs, and today we're just going to look for groups of 3 instead, okay? So for the first example here, if I want to know what's the cube root of 16, I already have the prime tree here. We have 2 times 8. I'm going to break that down to a 2 times 4 and break that down into a 2 times 2. So now instead of looking for pairs, we're going to look for triplets. And right here is a group of 3. So I'm going to take this out. The 2 is out. And then what I'm going to leave inside is this one red 2 right here. Now we're just going to leave it inside, though. Don't forget to put the cube root symbol with the radical. It's not just the square root of 2. We got to put the cube root, okay? Now we can check to make sure we're right. Let me get my calculator out. We can take here the cube root. Oh, actually, I don't think I can do it on this calculator. I would need Desmos. So let's get here to Desmos real quick. Sorry about this. All right, so we're trying to take here, we need the cube root. So I'm going to put a 3 of 16. And you can see it's like the 2.51, blah, 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 blah. So now let's take our current answer when we simplified it, which we simplified it to be 2 times the cube root of 2. And let's see if we get the same thing. So I'm going to have 2 times, and then now we're going to do the cube root of 2. And you can see we get the exact same answer. So that's how I know we did everything right. Okay. All right. Now back over here. For the next one, when we're trying to simplify the cube root of 54, again, the prime factor tree is the same thing as earlier in the unit. So this is a 2 times 27, which breaks down into a 3 times 9, which breaks down into a 3 times 3. So we've got our prime factor tree. And now what we're going to do is, again, just look for any triplets. So right here is a triplet, so 3 comes out. And then what we're going to leave on the inside, here we have a 2. So it's 3 times the cube root of 2. Careful not to write your answer like this. Sometimes I see stuff that looks like this. And to me, that looks like 3 cubed times the square root of 2. So just make sure, again, you can see I'm putting the little 3 up here with my number in blue so that you can see it's the cube root of 2. All right, now for the green one, when we're trying to take the cube root of 125, I want to know if there's any number times itself, 3 times, which gives me 125. And when we do the factor tree, we can see that it's a 5 times 25, which is a 5 times 5. And when we circle this out, everything comes out. And there's nothing left inside. And so this means that 125 must be a perfect cube because 5 times 5 times 5 gives me 125. So this one is a perfect cube. 125 is a perfect cube. And if I had kept going on this page right here, I would have had like the 5 cubed, which would have been a 5 times 5 times 5, and we would have gotten here that that's a 125. So when we see here the cube root of 125, we know that that's a perfect cube, and here this would be a 5. Okay, sorry about that. All right, so we took care of the first three. Now let's take a look at this example here in purple. So we've got the cube root of 320. So again, just break down that prime factor tree. It's a 2 times 160, which is a 2 times 80, which is a 2 times 40, a 2 times 20, a 2 times 10, and a 2 times 5. So we've got a lot going on here with this one. So let's go after our triplets here. I see this is a group of 3 2s right here. So I'm going to take this out. That 2 is out. And then right here, I actually have another set of my 3 2s. So I'm going to take out another 2. And then what I'm going to leave in, it looks like right here is just the 5. So I'm going to put here, I've got the cube root of 5. And the 2 times 2 that I took out, I'm just going to go ahead and multiply that now to be a 4. And I can rewrite that now to be a 4 times the cube root of 5. And again, to check, if you had Desmos, where you can click right here and then type in a 3 so that you know it's the cube root. And then this would be of a 320. So we've got some long, crazy decimal here. And we said that it's the same as seeing, whoops, sorry about that, a 4 times the cube root of 5. So let's make sure we got the same thing. 4 times the cube root of 5. And you can see we get the exact same answer, so I know I'm simplifying the same way. It's the same concept as putting in a 4 over 8 and getting that decimal and asking, did I reduce it correctly when I see, whoops, when I see this fraction? And when you get the same thing, you know you reduced it correctly, so you know you simplified it. So same concept here, okay? All right, and then one more up top, we've got the cube root of 75. So I just broke that down into 3 times 25, and then that's a 5 times 5. And when we look here, if I'm trying to circle anything, there's no triplets for me to circle. So for this one, it's going to be already simplified. All right, and let me just change the font of that one. So it's already simplified, kind of like I couldn't reduce a 3/8. I can't reduce that. This one's already simplified. Okay, and I'll circle that in orange. Now these didn't have any variables in them. The ones down below kind of kicking up a notch with some variables. And so you can see here, I've already got the factor trees again done for us. So this one, the example I've got here in the notes for y'all is that there's already a number taken out, but then it's times the cube root of 54. So I've got 2 times 27, which is a 3 times 9, which is a 3 times 3. And right here, I'm going to take out this group of 3s. So the 5 that was already out, I just now need to multiply it by the 3 that I'm taking out here. And then I'm going to leave here inside the radical, I've got just this. It's a 2. And I can't forget about right here to put the 3 for the cube root. And so the 5 times 3, I'm just going to erase that now and make that a 15. So we've got a 15 times the cube root of 2. 15 times the cube root of 2 for that one. All right, now for this next one, it's the cube root of 16x to the 5th power. So again, prime factor tree, 2 times 8 gives me the 16, which I break down into a 2 times 4, which I break down into a 2 times 2. So I'm looking for triplets. I've got a triplet right here. So I'm going to take the 2 out. This x is going to stay in, or sorry, this 2 is going to stay in. This 2 is going to stay in. And then now let's look at, again, the variables here for the first time we see we've got an x, 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 x. And we're looking for triplets still. So I'm going to see a group of 3 here. So this x comes out while these are going to stay in. I've got 2 that are going to stay in, so x squared stays in. All right. So we have 2x times the cube root of 2x squared. And again, this 2 came out, this set of x came out, and then I left a 2, and then my x squared inside, and then that's just the little 3 for the cube root. Okay, so I'll box that in red so it stands out. And here for this third example, unlike a number already being out, this one has a letter that's already out. So we'll deal with the letter that's already out in a second. And then we've got the cube root of 32m to the 4th power. So we're looking for triplets. I've got 32 is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. And when we go after a triplet, I see a triplet right here. So 2 is out. Now I'm going to put the m that's already out. I don't want to forget about that one right there, okay? So m and now times 2 is out. And then again, I'm looking for the m to the 4th power. I need a triplet here. So another m is coming out. Another m is coming out. All right. Now inside the radical still, we're going to leave this 2 times 2 2 times 2 is 4. And there's one other m that we didn't take out, so there's a 4m, the cube root of 4m. Now, when we took out the m that was already with another m, that's going to be m squared. And we also took out a 2. So basically, we took out a 2, and then the m going with the m that's already out is the m squared. And then so 2m squared is going to be times the cube root of 4m. And again, I'll box this in red so it kind of stands out. Okay, good. So 2m squared, and then that's a cube root of the 4m. And now we're down here to our last two examples. So for this one here, we've got the cube root of 27 m to the 4th n. And you might remember that 27 is a perfect cube. The cube root of 27 is a 3. So we should be able to see here when I have my factor tree, that comes out. And there's nothing else in terms of the number. But for the variables, I've got this group of 3, so the m comes out. And then what I need to leave in is an m and another n. So we have an m, and n stays in for the cube root of mn. And then that's times 3m. So 3m times the cube root of mn. And last but not least here, there's no number under the radical. It's just an x to the 4th and y to the 7th. So if I have x to the 4th power, I listed that out here, and here's my y to the 7th power. So again, when we're trying to find the cube root, we're going after triplets. So x comes out. Here's a y that comes out. And then another y that's going to come out here. So what we took out was an x and then a y squared. And then what we're going to leave inside the radical here is going to be times the cube root. We have an x and then a y. So that's a little long. I can erase that there. So this one is an xy squared times the cube root of xy. And that takes care of this video. At this point, you're just going to continue practicing on your own. You just got your factor trees, and then basically for today, you're looking for triplets, okay? Triplets. And that concludes today's video. Thank you for watching.